We are very excited for our next speaker here. She is a senior fellow at Bruegel, which is a European think tank that specializes in economics. She's also a professor at the Department of Management at the KU Leuven and has been a policy advisor to the European Commission. She's well known for her research on science and innovation. Please welcome Professor Reinhilde Veugelers, who will present the report with the title Europe, the Global Center for Excellent Research, and tell us about how to organize research so that it promotes excellence. Perhaps you can also tell us if Center of Excellence is a good way to do this.
Of course.
The floor is yours. Yep. Thank you.
Thank you for inviting me here on this conference. I know it's always a challenge to present after lunch. It's also a challenge because I'm an economist, and it's also a challenge because I'm Belgian, which usually is associated with some level of anarchy. So I'm not sure I will be able to deliver on all the promises that you have raised here in terms of being able to answer this question of how good is it a policy to invest in research excellence, and how good can we actually do a job on this. So okay. Yeah. So as already was mentioned, so we've been working quite a lot on trying to see to which extent research excellence is really important as a driver of economic growth, and what role Europe can actually play in this, and what role European policy instruments can actually do in terms of ensuring that Europe has this role as a center of excellence for research here. I'm trying to summarize a bit the report that we did on this, where we first will identify what are the trends in the global science and technology landscape and what role Europe plays in that, and then to look at indeed European policy instruments, particularly its research and innovation framework, and most notably it's the ERC instrument, which is the most pivotal instrument for supporting research excellence. How has this contributed, and can we learn on the way anything that could actually help to improve the future design of this? But before I go into this, perhaps also a bit situating the context in which we currently are, and how that drives actually a different perspective on research excellence here. So first of all, I think an important point to note is this shift in science and research production function, where we had new digital technologies, big data, AI, which is affecting a lot of industries and sectors, but also the way in which science is being done here. And where you could have similar concerns like you have in other industries, that big data, digital technologies, concentration in few players would also actually be what you could expect in science, is that this use of these technologies and research infrastructure creates more advantages for large scale here, and would mean that only a few number of players would actually be able to deal with this technological opportunity here. On the other hand, there are also quite a lot of others which say that the low-hanging fruits have already been picked, that's much more difficult to come up with the next big idea here, and that there are diminishing returns to keep on working in the same areas here. And if you combine these two, then it would actually really be that the next winners would be those that can actually play on completely new areas here, and again would emphasize the need to be radical enough from the existing fields here in order to be the next winners, where these next winners will definitely have an advantage of that big scale here. So that's one important trend that we might need to look at. If that's the case, then there would be much more concentration and fewer scientific players here. That could be countries, that could be labs as well. There is also another important trend that we have been seeing already since a long time, is this pressing societal challenges, which are really big, and particularly they're big in terms of requiring answers that crosses traditional scientific boundaries here. So like the examples of climate change, the diseases, the pandemic that was also raised by Jurgen this morning. Lots of these grand challenges require crossing a large scale of different scientific perspectives in order to be able to deal with these societal challenges. And then the question is, can the incumbent science system deliver and deliver in time by being able to cross these different, to build up that critical scale, which is not really scale, but scope in terms of combining all these different disciplines here. And then another important shift to mention is the shift in the global science and technology landscape in terms of geography, where we had really many decades of leadership of the US, a story of Europe catching up with the US, but now also a very important new pole, which is China. You could see this as a threat in the sense that that would mean more competition from other parts of the world. And if you see that in a zero-sum game, the more China wins, the less we would, the US and Europe would be able to win. But you could also see it as an opportunity for win-win in the sense that we now have a much more global and broader and bigger science and technology capacity for which everybody can win by specializing on those areas where you have a comparative strength and where you can collaborate and attract talents from a much broader scope here. But in any case, what it shows is that, again, it will be top players here, but there is much more turbulence at the top in terms of new scientific leaders that come up here. So that's definitely something to take into account in terms of when we're looking for research excellence. It's there are tendencies that would suggest more concentration and fewer players here, but enough turbulence in terms of who these new players would actually be here. And then other important trends that I have to look at is in terms of the public funding context for research and science here. Particularly in Europe, we have problems in terms of low growth and associated austerity here, which means shrinking public budgets, including for research here. But what's perhaps even more important is that these shrinking budgets is very uneven in the sense that the countries that are already strong in research, there we don't see this cutting in budgets here. On the contrary, they sometimes forge ahead, while the cutting in the public budgets is particularly in the more weaker countries, in the south and also in the east here. And so that creates, again, a lot of divergence and concentration of science and scientific power in a number of countries that are already strong here. Also, in terms of not just the size of the budget, but where the budget will actually also be spent on, much more emphasis in terms of trying to identify where the impact is of this research funding and the impact, then measuring not only in terms of scientific impact, but also in terms of economic and societal developments here, and very often also of local economic impact here. Local economic impact, and because politicians also have a shorter term horizon here, very often the impact needs to be short term, and that makes them very often very risk averse here, particularly for those kind of science that would only generate benefits in the longer term here, which is typically the case for the more risky approaches here. There's also way more emphasis on evaluating, and when we are evaluating, particularly at larger scale, we use a lot of evidence that comes from bibliometrics, and bibliometrics very often, because the way in which the indicators have been constructed, emphasize a lot of short-term impact here, don't always are able to capture the more longer-term impact here. Also, and it was already mentioned this morning too, is that you see in many countries, not just only in Sweden, but also in many other countries, a concentration of funding on excellence here with programs for star researchers, but also for top institutions and leading countries here. So the funding is also way more, so there's a tendency to having it more concentrated in fewer players here. So overall, so it's not only that the scientific system itself is could be concentrating more on fewer players here, but also the funding follows from that and will actually stimulate even more, perhaps, concentration in fewer countries or fewer top institutions here. So that's why this topic of concentrating research funding in excellence, is that there's definitely an important trend these days to look at here. So with that context in mind, what role is there for Europe in total, and the different member states of Europe, in what role can they play in these global trends towards research excellence here? So one important point already mentioned is this change in the geography of science here, with new scientific poles, and particularly the rise of China. I think you all know this here, but just a few easy graphs to show this here. So on the top you have the share in world articles here, and then you see that China has really that's the light green area line here, has risen very rapidly and is now actually the largest producer of scientific articles compared to, has outdone the US. Europe is still bigger, but that's EU 29. That's still included. That's still included the UK, and that's an important player, of course. In the left side, you see, because of course we're looking for excellence in research, the way we typically with bibliometric indicators measure excellence is those articles that belong to the top 1% most cited articles in their field and in their year. If you look at that indicator, there you see that the US is still on top very much here. The good news is that Europe indeed has been catching up on this and is now has the same share of its of all world articles that are highly cited here. So really, Europe has done a great effort in catching up with the US. China is not there yet, but you see also there it's making important inroads here. Now, if you take it as what's the share of every region in terms of these top publications here, that's a zero-sum game. But what I would like to show on the right-hand side is that this increase in research excellence is something that's actually not so much a zero-sum game, but actually that every country, every of the major countries, has actually grown in terms of the quality of its research that it's producing. And the way to measure the quality of the research in a country or a region is by seeing how many of its publications belong to that group of world's most cited publications here. That's what you see on the right-hand side. And there you see that actually in all regions, the quality, all the major regions, the quality has actually gone up because more of their publications belong to these really important top one articles here. That holds for the US, that holds for Europe, also holds for China here. So all the polls actually win in terms of having a higher quality of researchers here. The rise of China, of course, is also very specific to certain fields, and that's what you see in this graph here. So you see that the rise of China is particularly strong in areas like computer and information science, engineering, material science, and chemistry. That's where really they are specializing in, and it's particularly in these areas that they also go for the higher quality increments here, because it's in these areas that they already are making the biggest progress also in terms of the high quality, and have actually in some cases already outdone the US and Europe in terms of not just the number of publications in these areas, but also the high quality number of publications here. So it's a very targeted area, targeted areas where they are making progress here. So Europe, I already mentioned, we've done a good job in terms of increasing our share of research excellence in terms of measuring the number of top publications that we have. That's for Europe in total, but if you look at all the individual countries, the good news is actually that this increase in the quality of publications has taken place in all the member states here. So it's not just we're becoming more important in Europe because all the countries, only a few countries are actually behind this increased story here. That's not the case. So it's definitely not concentration in fewer players which forge ahead here. The increase in quality takes place in all the countries here. Nevertheless, there is still also a strong increase in the very strong countries as well here. So the the glass is half full, half empty here, in the sense that everybody increases, but still the top countries are also still importantly increasing. That's what you see on the right-hand side. The country that actually is increasing the most in terms of quality, and it was already an important country, is Switzerland. And if you look at other countries like Denmark is also making very important inroads here. Sweden is not doing too bad either, is also increasing here, but it's not as strong as for instance, Switzerland and Denmark here, but still better than most of the other EU countries here. So there is indeed still, although everybody improves, there is still evidence that it's the really better countries that are improving even more in terms of increasing their research excellence here. So still some evidence in terms of concentration on fewer players here. I already mentioned that I still include the UK as part of our European research area here, but the Brexit will have an important impact here. So here you see the contribution of the different countries for all the top publications that Europe produces here, and you see that the UK is on top and is responsible for 30% of all our top publications here. That's it's not only because it's a big country, science country, but it's also because it's really very big in the top as well here. It has gone down somewhat over time, but very little. So it is a very important contributor to our research excellence that we might be missing if the Brexit scenario is one of a complete isolation of the two different poles here. So the point that we also wanted to make in the research that we were doing here is that within these trends of research excellence and that this growth of multipolarity in terms of more poles reaching that research excellence, how can we benefit from that? Is it a threat or is it an opportunity here? And we really want to emphasize the opportunity part of it, that it's a win-win situation for everybody. But so how can we benefit from a much more multipolar global science? And within Europe also benefit from a much more integrated European research area where all the different poles are actually improving in size. How can that actually help each other from further continuing to grow in terms of research excellence? Well, that actually requires that we're also active in two important mechanisms which we can benefit from that more global research excellence environment here. And that's on the one hand, international collaboration. International collaboration as an important gateway for building research excellence, because we know also from lots of studies that have been done on that international publications are on average of higher quality than national publications, if only because you're using much more complementary and strong research excellence when you combine international expertise here. So international collaboration is a mechanism to build research excellence and a way to benefit from that much more developing global research environment. That's one dimension. And another dimension is the ability to recruit researchers on the international scale here. So the international mobility of researchers is another gateway for research excellence, because again, those that are internationally mobile researchers are typically of higher quality than the ones that stay local here. So what we want to do is actually see the extent to which Europe and individual member states are actually using that international collaboration and international mobility of researchers, because that's actually a way to check to which extent they can actually build further their research excellence by thriving more in this from this global research environment. So let's have a look at first international scientific collaboration. And the way we typically do that is by looking at, again, publications, but now international co-publications here. So we know that European countries in general, if only because they're smaller countries here, are more likely to collaborate on scientific publications, particularly if you compare with the US or China, which are bigger countries here. However, the evidence also shows at the same time that most of these EU international publications remain geographically limited to within Europe here. So there is clearly also, could call it a bias towards international collaboration within Europe, not necessarily extending outside Europe. Still, the evidence does show, though, that indeed publications that are written by a European author with an extra EU partner is really way better. It's so the evidence. Well, this is one number, but it's always in that kind of order of magnitude, 3.75 times more often cited than a publication that would be purely European collaboration here. So clearly there is a lot of opportunity for international collaboration to lead to much better scientific output here. With extra EU partners, and it's particularly the US and also increasingly China here. However, if we look at what kind of patterns do we see actually that the collaboration of European countries with US and with China, although there are quite a lot of them, if you correctly factor in how big these countries are in terms of scientific size, that then actually it's actually much less than one would have expected on the basis of their scientific size. So that's what you see in the graph here. So if you look at all the different combinations of European countries with the US as well as with China, all these numbers are below 1, and that means that they are less than what you would have expected on the basis of the scientific size. The only bar that's above 1 more recently is the US-China one here. So US and China is one important tie which has increased over time and which is even above, somewhat above 1 here, indicating that the US and China are much more intensively collaborating than what you would have expected on the size, scientific size of these countries here. So that's reflecting that, that they are trying to actually, or could actually be trying to set up a virtuous circle of collaborating so that each of them would actually gain from that. And that's an opportunity that Europe doesn't seem to be exploiting. It's not only that we are below 1 with both the US and with China, but it's also not increasing over time here. That's again, perhaps somewhat of a bias that's induced by working together within Europe here, with that biases or diverts attention away from collaborating outside Europe here. Just for Sweden, I also looked up the numbers on that. So here you see, so the bullets identify the share of with whom you're collaborating, and the biggest one, of course, is the US. But if you factor in the size of the US, you're actually way less than what you should have expected on the basis of how important the US is in the scientific landscape here. So it's really one of the less important or underrepresented partners here. China is the same, although about 10% of your co-publications are with China. It's still much less than you would have expected on the basis of the size of China as it is today here. And I don't think it's a surprise that the countries with which you are more than collaborating with, more than you would have expected, that's the Scandinavian connection here. So that's Denmark, Norway, and Finland. They have already traditionally been very strong, but actually have also even grown over time here. So that's definitely a Scandinavian connection that's overrepresented compared to the size, scientific size here. For all the other European countries, you see that it's often below what we would have expected, but it's improving over time here. And I tend to interpret that as a result of the ongoing process of the European research area here, which emphasizes intra-EU collaboration here. That's what you definitely see in the data. So overall, so for Switzerland, sorry, Sweden, you do see international collaboration, but you see a lot of emphasis on the Scandinavian, on increasingly now also with other European countries here, but much less so with outside extra EU partners here. And given the shift in terms of where research excellence is, these are partners that are underrepresented here. So that was this international collaboration. The other mechanism I mentioned that countries can use in order to benefit from this global scientific excellence is by recruiting of international talent here. So that's the international mobility of talent. So one way of tracing this is, it's not so easy to find good data on that, but again, we use publication data, and there we trace authors on publications, and if they change national affiliation, that's what we record as an international mobility of authors here. So it's really, it's an imperfect measure because it's only authors that we can trace over time here, but it does give some idea in terms of where is this mobility taking place, and also the quality of the authors, because we know the publications and we also know, are these top authors or not. So we can also identify not just who is mobile, but how good are these mobile authors here. So what you see on the left side is just the mobility of researchers. So for every country, you can calculate how many authors come from outside, and also how many authors you actually lose as well, that show up on publications in affiliations in other countries afterwards here. So what you see is that here, the countries are also rated on how good they are in terms of their local science base. And what you see is that actually, so Switzerland is a very open model here. The US is in principle also very open, but because it's big, of course, it's way more difficult to get large numbers of incoming and outgoing here. But what you see is that overall, the good countries definitely are also very open. So they attract a lot of researchers, but what you also see is that the outflow is very highly correlated with inflow. So countries that are open, they're able to attract a lot of researchers, but they're also very interesting countries to attract researchers from, because they also have very typically also a high outflow. And then, of course, it matters what that quality is in order to see whether countries like Switzerland or the US are not just competitors in terms of attracting research talents, the best research talents, but since there is also quite a lot of outflow from these countries, it is also important to see them as possible sources where you as a country can actually attract from as well. So you see actually Sweden is doing pretty well on this. So it is indeed using international mobility of talents because it has a high share of its research, its authors coming from outside. But of course, it also loses a lot of countries, a lot of authors as well here. So then, of course, it really becomes important: who are we attracting and who are we losing in terms of research quality? And that's what you see on the right-hand side. So there we actually measure the quality by the quality of the publications that these authors had before they moved, in order to check the quality of the brain drain or the brain gain that you have from attracting or losing researchers. So we express all these qualities relative to those that would stay local purely here. So it's always relative to the local ones that are immobile here. So if it's larger than one, that means that the ones that are that you are attracting, so that's the new one, would be better than the ones that you actually already have. So that means a brain gain from attracting researchers here. So what you see is actually that that brown area is actually always larger than one. So that actually means that attracting researchers from abroad is always a brain gain. The ones that you attract are always better than the ones that you already have. So you can increase your research excellence by international mobility here. That holds even for the better countries like Switzerland and like the US. It holds even more so for countries in the back here, which are less strong here. So they gain even more from attracting. Of course, they are attracting less, but nevertheless, it is a mechanism to which they could actually be winning in terms of research excellence. The ones that are flowing out, so that's, do we have a brain drain if people move out of the country? So that would mean that the outflow, which is the green bar here, if that would be larger than one, it would be an outflow, a brain drain. So what you see is that this is, for most of the countries, somewhere around one. So there is, but higher than one. So that would mean that indeed also the outflow is a brain drain, but it's relatively restricted here too. But what you see is that actually for these countries that are in the lower part, so which are weaker science countries here, for them the brain drain is actually way more important. So the ones that are leaving are really the better ones compared to the locals, and so for them the outflow of researchers is really an important brain drain here. The US is actually the only country in this set where the brain drain is not there. So although they lose a lot of researchers, see, the ones that they're losing are actually worse than the ones they keep. So they actually, the US is one example, is one of the better examples in terms of benefiting from mobility. Although they're very good, they still attract even better ones here. And although they lose a lot, the ones that are leaving are not the better ones here. So overall, they win. They're the most likely to win here. And if you look at China, so China in this respect, you see that the ones that it's actually losing is in terms of relative to the quality here. So they're losing very important research talent. So there's definitely a brain drain going on here. The ones that they recruit back are better than the local ones. Most of the ones that are new are returnees. So these returnees are improving the scientific capacity of China here, but you still see that the ones that are returning are not better than the ones that are left here. But that creates also a lot of opportunities for other countries, and the US is definitely already using that a lot. But also for Europe is the ones that are leaving China are still so much better than the local ones here that we would all benefit from. All the countries actually would benefit from attracting Chinese students or scholars here, because the ones that are leaving are so good, such a brain drain that they are a brain gain for all the other countries here. And that again identifies this win-win scenario here, is that we could all win from attracting Chinese, the high quality of the brain drain here. And China at the same time is also winning through the returnees. And although these returnees are not as good as the ones that are leaving here, they're still way better than the ones that are local. So it can use the returnees to increase its local science here. So recruitment of international talent is really an important mechanism for countries to build in a win-win its research excellence, and could actually explain that this growth towards excellence can actually happen in multiple countries here, as long as we can benefit from that international mobility. It was just in the case you wanted to see Sweden here, and you see again, so Sweden, so these are the numbers in terms of Sweden compared with the other northern countries here. So definitely Sweden is in terms of the inflows and outflows, it's a very open country here. And in terms of the quality, what you see is that it wins from the ones that it's attracting. It also loses from the ones that are leaving here. But it wins more from what you are recruiting than what you are leaving here. So letting this mobility, this open mobility of researchers flow is important to increase the quality of the Swedish research system here. So this overall, in terms of setting the scene of the global changes in research excellence, and how countries actually can make sure that they remain and that there is room for all countries to benefit from that global research by increasing their research excellence, but requires that we're using these mechanisms of international openness through collaboration as well as mobility here. So the next thing we wanted to look at is then what's the extent to which the EU public funding would actually help to ensure that the EU is well positioned on the global research excellence frontier, and whether it's sufficiently using this mechanism of international collaboration and mobility of researchers to reach that research excellence. So the good news is that the EU funding for research is something that through the framework programs has been gradually increasing, at least in terms of shares of the total budget here. And then the total EU budget. And then the extent to which it's allocated to excellent science is also pretty well stable, in the sense that 1/3 of the whole program is dedicated to this Pillar 1 excellent science. So definitely excellent research is a high priority in what the EU funds. And within that Pillar 1 on excellent science, you have the most important instrument, which is the European Research Council, started in 2007, which of course, continuously has to fight for its share of the budget here, but has seen an increase in the budget and importance over time. So in terms of budgets, there is a willingness for the EU to actually fund excellence in science increasingly more than what we've seen before. How this EU budget for research excellence then flows to the different member states. So does does it create more divergence between winners and losers or not? So if you look at the success rates within the ERC, that's very heavily correlated with the quality of the research in the member states here. So that's what you see in this picture. So you have here the success rate. Here you have the quality of the science in a country as measured by how many of its publications it has in this global top 1%. And you see that all the countries that are doing very well are also the ones that have that high scientific quality, just reflecting that the ERC is very good in picking the high scientific quality in the different countries. There are a few outliers. Israel is doing way better than that. And Denmark is actually doing somewhat less than what you could have expected on the quality of its research here. So in that respect, the ERC does concentrate further research funding towards those countries that have already a very strong own research scientific excellence. And within the country, there is also a very high correlation. In many countries, the ERC grants go to a few top institutions here. I've looked up, for instance, for Sweden, the top 3 biggest recipients of ERC grants in Sweden are the 3 top institutions, Karolinska, Lund, and Uppsala here, and they already account for 55% of the ERC grants. So high concentration of that kind of instrument, but the concentration goes to those countries that have a strong scientific excellence and to those institutions that have a strong scientific excellence here. How does the framework program contributed to research excellence? So again, we have had a lot of evaluations of this, and the evaluations usually are pretty positive in the sense that those publications that are funded by FP7 are typically of substantial higher quality when you compare that to the other publications of a region here, and that goes up till 3 to 4 times higher impact factor as compared to the ones that are not FP funded. So in that respect, FP does pick scientific excellence. And if you look at the instrument, the specific instrument ERC, 7% of its publications are in the top 1%. So that's 7 times more than what you would have expected here. So definitely the ERC is also picking much more these top publications as an outcome here. So in that respect, the answer would, the evidence would seem to suggest that indeed the funding that the EU provides does help to build scientific excellence and put Europe in as a center for scientific excellence. Does it also support these mechanisms that we have identified that countries and regions can use to build on that global scientific excellence? So does it also stimulate international collaboration and international mobility of talents here? So international collaboration definitely is stimulated. That's in many programs of the EU also enshrined as a kind of criteria. You need to collaborate with others, be it that most of that collaboration is with other member states here. So that's a bit of bias that the framework program really builds in, is that it does support international collaboration, but 90% of the funded international scientific collaboration remains within the member states, the 28 member states here, and only very few are with even associated countries like Switzerland or Israel, and even less so with third parties here. So that's the positive news is that it does stimulate international intra-EU collaboration, but with the possible danger of diverting attention away from collaborating with other partners here. And that's a bit unlucky in the sense that those collaborations with extra EU partners have an even higher quality premium than the collaboration with the intra-EU. So intra-EU collaboration does improve the scientific quality, but collaborating with extra EU partners would have an even bigger jump in terms of quality here. And also we checked for the ERC, the specific instrument for research excellence. A lot of ERC publications are internationally collaborations here, including extra EU collaborations. And like, for instance, 75% of the top 1 extra EU collaborations are with the US. So ERC publications do also play on that international collaboration to build excellence. The other dimension was the international mobility of researchers. Is that something that the framework programs would actually stimulate, and uh, would be the story behind why framework programs would help build research excellence? Is because it stimulates mobility of researchers. Here, again, it's not so clear to find that evidence, particularly also because a lot of that international mobility, like we've seen for international collaboration, if it happens within the European area. So if you look at the ERC, there a quarter of all the applications of the ERC come from non-citizens here. So foreigners that are not citizens are the successful applicants in ERC, 1/4. That's not nothing, but it's also not massively important here. So it's 1/4. And also important again to note is that most of that inward mobility is from within the EU here, because only 1/4 of the foreigners that you attract, the non-citizens that you attract, come from outside the EU here. So the ERC in that respect is not so much used as a mechanism to which you can actually bring talents from outside the EU, particularly again US or China here. And then if you look at which country is actually most using the ERC grants to attract foreign talent, that is the UK, has the most applications from non-citizens. So the UK is really the entry port for which a lot of foreigners, certainly from outside the EU, are entering into the EU area. Question again is, with the Brexit, are we losing then that entry point or not? Also, Switzerland and Austria are very open systems here. But again, they're much more attracting, when they're attracting foreigners, attracting that from within the EU rather than extra EU. Then you see Sweden. Sweden is not doing bad in that respect. So it's also a lot of its ERC grants that it is attracting. It is attracting with these ERC grants non-Swedish here. But so, and it's above 1, so it's more than what you would have expected compared to the size of Sweden here, but it's less than, for instance, the UK or Switzerland or Austria here. So in that respect, there is still room for improvement of using these ERC grants to attract foreigners from abroad here. Okay. So overall, if I want to summarize a bit what the effect is of the framework program, that's definitely there are positive news in the sense that the instrument is good in terms of committing to research funding to excellent research here. There is evidence that it does lead to more higher quality research, not only for the top countries but also for the weaker scientific countries here. It does improve international collaboration, but be it that this is mostly intra-EU here at the cost of perhaps biasing against collaboration from outside the EU, and that definitely the attraction of foreign talent through these mechanisms is something that definitely can be improved further. And then I would like to use my last 5 minutes to zoom in a little bit further on the ERC as an instrument for stimulating research excellence, because it's a very specific instrument dedicated to research excellence. And the question really is, does that instrument work in terms of improving research excellence? But a fundamental question, and there has also been in the morning regularly mentioned, what do we mean actually with research excellence? What is the kind of research that we want to fund with this instrument here? And that's really the focus on, in the ERC rhetoric, it's research excellence, but it's always a bit more than just research excellence. It's this high gain, high risk type of research. That's basically what the ERC instrument's been designed to set up. That, of course, entails dimensions of excellence, but it's more. It also has to do with big impact, really big impact, so breakthrough type of research, and not only big, but also wide, so impact that actually affects very many different areas as well. At the same time, also risky, because these big breakthroughs very often come with high risk here, and risk very often is associated with new types of research that are being done here, and a lot of new research is research that crosses traditional disciplinary boundaries here. So a lot of different dimensions than just purely excellence here. It's also looking at these breakthroughs, this risk-taking, and this risk-taking coming from novelty and crossing disciplines here. And so then the question is really, so to which extent is the ERC successful in funding, in selecting and instigating that kind of high gain, high risk type of research here? That's also why it was designed here. It was also because it was believed that particularly at the EU level, this would be an instrument that would be very complementary to other instruments here, because that high gain, high risk, and particularly the risk taking is something that it's much more easy to organize at a higher EU level, where there is more room to take risk as compared to the national funding instruments here. And also as a way to counter a bit the general opinion that's out there, is that a lot of funding, public funding, particularly in member states, is becoming way more risk averse. So can this instrument somewhat rebalance that kind of risk aversion that we've seen in other funders here? It was definitely designed in such a way that it would this would lead to much more risk taking in the way in which it was structured in its grants, because what we've known from the other funding instruments is that if the grants are short-term in nature, like 3 to 4 years, then it's really very hard to recover from failure. And that biases against risk-taking here. It was also mentioned this morning how important it is that you have a window of 10 years. That's enough in order to recover from failure here. And so it's this long-term window that's really important. But a lot of normal grants are too short so that you cannot recover from failure. And that means that you have to go for the low-risk types of projects that are sufficiently certain to generate results within the time frame of your projects here. What you need to have is really funding that's what's in the literature called protected space, that is sufficiently big and sufficiently long that the researcher no longer has to have this push from, I need to make sure I look for new funding here. And so you need to the funding needs to give a protective space for the researcher, that he can really go in the areas that he wants to do and is freed of any kind of discipline of looking for the next funding here. So that's why size and length of the funding is a very important dimension here, and that, of course, is something that that the ERC grant definitely entails. Another design characteristic that influences risk taking is the review process. Reviewers very often are peers, and peers appear to actually, in research that has been done on this, appear to be quite risk averse here. Very often they have to have a consensus, and consensus leads to avoiding more risky ones here. It's much more easy to find a consensus on lower risk type of projects here. And also reviewers always tend to look for, if there's no crystal, there's no grant, so there has to be already some preliminary results. So on average, we know also from a lot of evaluations that panels tend to be very risk averse here. And that's why it's also important to make sure that you design your panels in such a way that they're willing to take more risk here. So what the ERC definitely in its design was focusing on, first of all, it had as a clear mission that it would go for the not just the excellence, but really the high gain, high risk, the ones that shifts the frontier here. The panel members were really selected globally on excellence here, and were giving a very clear instruction is not to go just for the excellence, but really for not avoiding risk, but really going for the high gain, high risk here. And our grants were big and longer term here, so should be giving that protected space here. So it was designed like that. Did it also deliver? So the first question is, what is the way to assess high gain, high risk type of research? How can we do that actually? The headline KPI that the Commission imposed on the ERC was what share of publications from the ERC are in this top 1%. That if that's your KPI, that just measures excellence, and that's it. And of course, there was a target that was very easily met. So the target that was set was 1.6. And I already mentioned we had 7%. So we were way above that KPI here. But of course, the question is that the KPI that really measures high gain, high risk here? So we had to look for other indicators to measure that high gain, high risk here. And that's, of course, that's still a bit of a tricky exercise, but the kind of measure that we developed in order to be kind of proxy for risk was a measure of the novelty of a scientific paper. And we measured a novelty of a scientific paper as, do you make new combinations of references from different areas here? And if you make new combinations of references that have never been made before, then we classified you as a novel paper. And we identified that those are papers that are taking way more risk here. And also the analysis that we did was indeed confirming that those kind of novel papers have all the characteristics of more risky ones. First of all, they're very rare. Only 10% of the publications make these new combinations here. They are likely to be really becoming breakthroughs, so they have a higher likelihood to be breakthroughs, but it takes a way longer time before they get a breakthrough here. So it's not within the 3 or 4 year window that you typically look at when you look at impact factors, but will take at least 4 to 5 years before they actually reach their big impact. So it takes a longer time, which is to be expected because it's risky, it's new, it takes a long time before actually it's recognized within the field here. Also important characteristic of this impact is that the impact very often happens in other fields outside your own field here. Makes it also more likely that it takes a longer time because the impact is a non-field here, but that also identifies how important it is in your evaluations to cross different disciplines here, because the impact very often of risky research is not in your own field, but will actually also be coming from other fields, and that expertise also has to be present in your evaluation in order committees in order to be able to select that kind of high risk here. So if we use our normal bibliometric indicators, the journal impact factors, they really measure impact in short time windows here. They would actually not pick up this more novel, high risk type of research here. So using our traditional bibliometric indicators biases against that kind of novel research here. So what we then did is and this just illustrates what I said, that this novelty has larger probability for breakthroughs here, takes a longer time and comes from foreign fields. So it's really measuring, although it's not a perfect measure of risk, it is associated with more risky type of research here. So what we then wanted to look at is within the ERC, does the ERC pick the projects with PIs that have profiles that have this high risk, high gain type of research here? That's one thing, so the selection. And the second thing we actually examined was whether there was any treatment effect here, whether if you get the ERC grant, you're more likely to do that kind of research here. And what we find was actually in terms of selection, the ERC does a very good job in picking the highly cited papers, so the excellence, that's no problem, picking those. But there was a significantly negative selection for high risk, so it biases against that higher risk type of research here. And that bias actually comes from the junior grants here. Those are biased against, not the senior ones, it's the junior ones that if they have done too much of that novel research, they actually are less likely to be selected here. And in terms of treatment, we don't find any treatment for high gain. So the fact that the ERC is scoring so well is only because of the selection, not necessarily because it induces more research here. We did find also no treatment effect for novelty, except for the juniors. So for the juniors, we do find that when they get these grants, they are much more likely to be going into more novel research as before here, because they're freed of this discipline of having to fund for the next time here. So for the juniors, there's way more bias against novelty here, and for them it matters way more to get a protective space here in order to be able to do the novel research that they would like to do here. So overall, that's my last slide here, is the lessons from ERC that we take in terms of how to fund excellent research is there is always a risk that there is a bias against risky and novel research in terms of selection. It's also not so easy with your instrument to induce more risky and novel research here, and that even when you designed or try to design your program as good as possible to deal with that high gain, high risk, there is always this danger of bias and lack of effects here. And this is because actually I think tolerance for risk is a much more general science system issue here. If your panel members operate within a system that is very risk averse here, it's very hard to induce them to be risk taking and select even for the instruments that you have designed here. And so trying to install a program that is embedded in a risk averse system, that's a very challenging so you really have to work on the whole system in order to reach your objectives here. So thanks for your attention here. And that was the major results I wanted to share with you for the discussion.